Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today also we are going to see in this episode related to image generation. In the rapidly evolving world of generative AI, innovation is key to unlocking new creative possibilities. So today we are diving into some groundbreaking papers that highlights just how far we have come from animating still image to refining complex scenes generation. These advancements are setting the stage for the future of AI-driven creativity, and we are here to explore them. You can find the full paper link in the description. If you reference these papers in your research, make sure to cite it. Okay, let me just go for the first paper. DIT3D exploring plane diffusion transformation for 3D shape generation. Different transformers have taken over AI, but can they revolutionize 3D shape generation? Yes, meet DIT3D, a diffusion transformation model that ditches the traditional unit and embrace transformer-based architecture for superior 3D shape creation. This DIT3D brings some key innovation. It utilizes 3D positional and patch embeddings combined with 3D window attention to optimize computationalized efficiency. Instead of operating on 2D images, it directly denoise that point clouds, refining structures with remarkable precision. So, and the result? Of course, higher accuracy and greater diversity and more detailed 3D models. And here, DIT3D outperforms existing methods across the border. So plus it enables efficient fine-tuning from 2D to 3D, leveraging pre-trained diffusion models for an extra boost. This work sets a new benchmark, proving that transformers are not just for text and images. They are shaping the future of scalable, high-quality 3D generation. So future improvements could extend this to even larger point cloud and more complex 3D environments. What do you think about transformer-based 3D generation? Have you come across any existing research on 3D diffusion? Drop your thoughts in the comment section. Let me just go for the second paper. AnimateDiff. Actually, that is the name. So, animate your personalized text into image diffusion models without a specific tuning. Dear friends, everyone loves the power of text to image models like Stable Diffusion. But what if you could take those static image and breathe life into them? That's exactly what AnimateDiff does. So it allows you to animate any personalized text to image model without retraining or tuning. Here's how it works. So AnimateDiff insert a motion modeling that model into an existing text to image model. By training this model on video clips, the system learns motion priors that can be applied to generate smooth animated images instantly. So whether you are working with anime characters or realistic photographs, this Diff generates fluid animation that maintains diversity and style of original models. It's like turning your imagination into a moving masterpiece. So with this framework, you don't need to fine-tune every single model. Once trained, it works on any personalized version of the base model and saving time while producing high-quality animated sequence. So next paper, it is collaborative score distillation for consistent visual synthesis. Dear friends, ever struggle with consistency when generating multiple images? So like when trying to create a video or a panorama. So collaborative score distillation, or which we just shortly said, CSD, has the solution. So making sure every images in a set matches in terms of style and structure. So the CSD takes advantages of certain varialization gradient descent to consider multiple images as particles that share their score functions. So this allows the model to integrate information across all images, ensuring they align seamlessly. So the technique ensures consistency across a range of applications, from editing panorama images to generating videos and even 3D scenes. So by distilling generative prayers across multiple samples, the CSD keeps things looking cohesive no matter the complexity of the task. So whether you're working on visual editing or synthesizing new scenes, CSD makes it easier to maintain harmony between all the elements, helping generative models reach their full potential. Okay, next paper, AutoDecoding Latent 3D Diffusion Model. Difference want to generate high quality 3D object with ease? AutoDecoding might just be the answer. So this paper introduced a method for generating 3D assets using a 3D autodecoder framework, no need for extensive camera supervision. And it core auto-decoding embeds learned properties into a latent space, so which can then be decoded into a volumetric 3D representation. So the beauty of this approach is it does not rely on complicated camera data, just 2D images or monocular videos. So making it much more flexible. Through robust normalization and denormalization techniques, auto-decoding can generate high-quality 3D models from both rigid and articulated objects. So the results speak for themselves, outperforming traditional methods across various benchmarking. Now, whether you are working with synthetic objects, real-world videos, or complex animation, auto-decoding offers an efficient and powerful way to bring 3D assets to the life. Okay, next it is efficient 3D articulated human generation with a layered surface volume. Dear friends, creating realistic 3D human models is crucial for gaming, VR and digital environment. But existing methods are either slow or lack detail. Enter layered surface volumes, that is LSV, a novel approach for creating articulated human models that are both high quality and faster to render. This LSVs use multiple layer of textured mesh around a basic template, allowing for fine detail like hair and accessories to be represented naturally. So this technique is super efficient, making it perfect for real-time applications, all while maintaining view consistency. By using alpha composition and differentiable rasterization, LSVs capture off-surface details without the slowdowns of traditional volumetric methods. Plus, it works beautifully with 2D GANs, allowing high-quality generations with minimal computational loads. And of course, thanks to LSV, so we can now generate articulated human figures with fine details and lightning speeds. So ideal for VR, AR and gaming experience where every second counts. Okay, next it is T2I, that is ComBench, a comprehensive benchmark for open world compositional, that is text to image generation. Different text to image models are amazing, but composing complex scheme with multiple objects and attributes can still trip them out. So that's where this T2I, that is ComBench, that is the name they specify, comes in. And a comprehensive benchmark designed to test how well models handle compositional image generation. And here this T2I ComBench consists of 6,000 prompts that focus on everything from color binding to spatial relationship, challenging models to generate coherent, complex scenes. But it's not just about testing. This benchmark is paired with new evaluation metrics and a technique called GORS that is designed to boost model performance. And here, dear friends, with T2I ComBench, the authors assess how well existing models handle tasks like object relationship and spatial interactions. The results highlights both the strength and weaknesses, so providing valuable insights into how to push text to image model even further. This T2I ComBench is a vital step forward in compositional, so text to image generation, offering new way to evaluate and improve how models synthesize, integrate multiple or multi-object scenes. Okay, dear friends, as we continue to break barriers in generative AI, these advancements are pushing the boundaries of what's possible. So from animating static image to generating intricate 3D models. So the intersection of creativity technology is getting stronger, offering timeless potential. So if you enjoyed this deep dive, let us know your thoughts in the comments below. And if you have come across any papers related to this topic discussed, that is, feel free to share them with us. Don't forget to like, share and subscribe for more updates on the world of generative AI. Thanks for watching, dear friends. So happy learning.